Hello friends, today I am back and I have come with a new topic which is IPv4 multicast overview. So let's get started and understand this topic. First I would like to talk about objectives of this session. First is resources of multicast. What are the resources do we need to study the multicast? Introduction of multicast. What is multicast and why do we need multicast? Why multicast? Yes, we'll talk about that. Components of multicast. So I have categorized the components, so we will talk about all these. So these are the resources we can go through and we can download from Safari. So these resources will actually help us to understand multicast. So TCP/IP version volume 2, this is a part of CCI, routing and switching. So this book you can study, but this will teach you entire multicast, but it will cover a lot of topics of multicast. If you want to gain more and more knowledge, then you can go with this second book, Inter-Domain Multicast Routing. Then you want a basic introduction and basic documentation, which is available on Cisco site. Then you can open all these websites here. I would bring here. First is routing TCP/IP volume 2. This will actually cover some of the part of multicast. So I would like to show here. Okay, so here we will see here introduction to IP multicast routing. So this book will cover IPv4 multicast addresses, IPv6 and multicast routing issues and lot of things about multicast. And the second book is Inter-Domain Multicast Routing. This book will actually give you a lot of knowledge about multicast. So you would see multi-protocol extensions for MPBGP, multi-topology routing in intermediate system, ISIS, specifies of ISIS. Okay, then we have here Cisco iOS IP configuration guide. This is the release number, and here is a document. It's a long document, you can go through and study this. So these are the resources we can use to study multicast. Then now I would like to talk about what is multicast. Multicast is actually the traffic reducing technology which can send data to a group. So I would say it transmits data to a group, not to everybody in the network. So the very simple definition of multicast we always hear is one to many. So it transfers data from one source to multiple destinations, means in a group. Where do we use this multicast? Mostly these are the examples I brought here: video conferencing, IPTV, distance learning, data center, the real-time applications like stock tickers. In stock exchange it is used, and online gaming as well. And nowadays we see video conferencing and IPTV. These are the most preferable examples. Now we talk about why do we need multicast. Then the first advantage of using multicast is it can enhance the efficiency of the network. So it controls network traffic and reduces server and CPU loads. That is one beauty. Second, optimized performance. Optimized performance, I would say, is it can eliminate traffic redundancy. If you have multiple paths and traffic is coming from multiple paths, so it can eliminate that redundancy. Then the third advantage of using multicast is distributed applications. So you can have the environment in the network where one application can be distributed in a group. So one application can be the server application and the remaining all applications can be the client version, and the server version can feed all the client versions in using a single stream. Now the last one is more important, I would say. In multicast, sender does not care who the receivers are. In unicast, always we need to know who the destination is, and we need to have information about sender and receiver. So every time when you send data, there is single unicast stream between sender and receiver. So sender has to care who the destination is, but in multicast, whether the receivers are available in the network or not, it doesn't matter. Sender will start streaming immediately, even the receivers will ask and will not ask. So here I would say the example is like TV. When you watch TV, even you watch and you don't watch, still you receive the broadcast stream. It is similar what we receive in multicast. Now here are two examples. One is with multicast and one is without multicast. So with multicast we can get this scenario where a single stream can feed multiple recipients, but this is the example of unicast. So in unicast, every time whenever any user asks for the data, they have to have single stream. So number of users, number of streams. So streams means the flow, traffic flow. So number of flows, they can give the burden to the server and to the network bandwidth. So that's the disadvantage of using a unicast in a video environment and the gaming server environment. With multicast, there is a single stream will go to the network and it will be flooded throughout the network. Then whoever the recipient want to join, they will ask for that stream and immediately they will join that group. That's the beauty of multicast. So here if I say the bandwidth of my link is 10 Mbps, okay, and one user consumes 2 Mbps, then I can have a number of streams hardly 5. If I increase, then of course the performance will be slow, the network bandwidth will be utilized 100% and the traffic flow will be slow. In server environment, you can send single stream that will be distributed among all these recipients. So using single stream, using 2 Mbps, you can feed number of users, multiple users. That's the beauty of multicast. So single data feed generated by source for all interested recipients. Whoever are interested, not interested, stream will constantly go. So single forwarding decision for all the recipients. That's the beauty of multicast. No traffic to uninterested. Whoever are not interested receiving that traffic will not go to that particular user. So we will talk about that. We talk about the disadvantage of multicast. Disadvantage first is it is UDP based, so it does not have any acknowledgement, no packet guarantee, no packet delivery guarantee. So whenever you want to send information, make sure that information is simply going. There is no acknowledgement between recipient and the server. So sometimes you may receive duplicate packets in multicast. So here is the example. I would say you may have this type of link in your environment, so you may receive the same stream from this side and this side also. There are some mechanism to stop that stream or this stream, any one of them, but you may have sometimes duplicacy of data. Then I would say no acknowledgement of the data, out of order packet. Sometimes you may receive the packet early and sometimes it might get delayed because there is no sequencing mechanism used in multicast. So you may have out of order delivery. It is similar to the television. When you watch television, due to any weather issue or any rain issue, you might not see the picture properly because of out of order frequency. No congestion avoidance mechanism used here. So whenever your traffic is more in the network, there is no mechanism here in multicast can be used to avoid that. Now we can talk about how multicast works. So very basic example I have brought here. First, the sender starts sending an application data or any video application data. So sender will always say like that, I am the 1.1.1.1. For example, this is the IP address of server, and I am sending this feed to 224.1.1.1. Then it will go through the network. Whoever devices in the network are, they will receive this stream constantly coming from the server application, and the recipients are not asking as of now. If they ask anything, then recipient will ask this way, I don't know about the server, means the recipient, so I am keeping here asterisk, I am unaware about the sender, and the server is also unaware about recipient. So in that case, I am putting asterisk, so I want to join whoever is sending the stream to this group 224.1.1.1. Then this is how they will create a multicast tree. Then they will start forwarding data. This is the example of that. So source application starts sending to a group. So group means whoever are interested, they will join this group and they will start learning or listening to that traffic. Then router will create a loop free path between server and receiver, so there is no loop and traffic can go without any issue. And the rest of devices whoever are not interested, they will not receive this stream. Now we can talk about multicast components. So I have categorized these components in three categories. One is addressing. So in multicast, again we have multicast IP and multicast MAC address. So we have layer 2 address and layer 3 multicast address. It is similar to unicast, layer 3 address and unicast layer 2 address. Then the second category is a control plan. The control plan actually defines learning. What will you do? So what will you do with the traffic? How will you forward that traffic? And how many number of paths available to forward the traffic? So actual controlling of the data is done by control plan. So it is similar to a bus driver. Before sending bus to any city, the bus driver must have a route map. Even the passengers are in bus or not. So before going to the city, driver must have the proper path, the number of streets, the number of routes, and the number of stations, stops. Everything should be in a map. So we call it RIB or FIB. So we call here is RIB, routing information base. So router also must have this kind of information before forwarding any traffic. So we call it control plan. So control plan means learning what will you do. The data plane is where actual packet movement happens. So here are some of the examples where the actual packet movements happen, and some of the technologies are the features we can use to prevent the loop and can find out the exact outgoing interface and incoming interface. Now I would like to talk about layer 3 multicast addressing scheme. So we have multicast class D in IPv4. So that starts from 224.0.0.0 up to 239.255.255.255. Now this address 224.0.0/4 up to 239 categorized in some of the addresses. So first type of address is link local address in multicast. So link local address is used for local network, and these types of addresses are not routable. So the range is 224.0.0.0 up to 224.0.0.255. So this type of address is used by like routing protocol, and some of the protocols they don't want to send their data beyond one hop. They want to keep the data in same LAN. Then the second category again comes, I have not written here, but that is called inter-network control block. So that is the next one. Inter-network control block. So this inter-network control block range will start from 224.0.1.0 up to 224.0.1.255. So this address range is designed for the network where packet can go throughout the network. So packet is routable if they use this address range. Then the next is source specific multicast, which is used for IGMP version 3. I would write IGMP version 3, and this is a fixed range. We call it source specific multicast, and this is reserved for source specific multicast feature in multicast. Then we have globe. Globe is actually the address was designed for experimental purpose, and this address is unique globally. You can also make it globally unique. So what you need to do is, if you have the ES number, autonomous system number, got from ISP, so it may be 2 bytes. So if you have 2 bytes ES number, so you can keep these 2 bytes here in this 8 and 8, 1 byte and 2 byte. Then you can make it global unique. So you may have like 64,135. You can convert this into binary and you can put here in between these octets. So globe is actually used now to make the global unique multicast address, and we'll see that later. Now we have administratively scoped. Administratively scoped is used for private network. So it is used for private. If you want to use in your office or somewhere where you are implementing multicast, you can use this range, and this is reserved for private. We call it administratively scoped. Now we have layer 2 multicast address as well. So layer 2 multicast address derives from layer 3 multicast address. So there is a mapping mechanism between layer 2 and layer 3 IP address. So how does it happen? We can understand that as well. So there are some rules we will need to think about that. So this is the range for multicast MAC address here. So we always need to understand, if you see this range, that belongs to multicast MAC address, and the remaining these we'll talk about how can we change that and map layer 3 multicast address here. So here we have totally 48 bits in multicast, as we know, multicast MAC address or any MAC address. So 48 bits. So MAC address 48 bits. So we need to care up to 25 bits, 25 bits, and remaining 23 bits we will have to bring from IP address. That is the beauty. How do we do that? Let's understand. So first 24 plus 1 bit, 24 bits here up to here, they are fixed, designed by OUI. Then we need to keep the first bit 0 always, even the first bit is 1 or any 0 also, you always need to keep this first bit 0. So these bits are always fixed. Last 24 bits we will bring from IP address, multicast IP address. And here is the link to convert multicast IP address to MAC address. So you can convert using your mind, or you can use a tool to convert it. So I will bring that website here. If you click here and here, so you write here any multicast address like 225.129.10, okay, and 20. I want to convert or anything like 2020, convert. So you can see these 24 bits are fixed. One bit should be 0, it is 0, and remaining all bits as per this. So we will understand the manual method to convert these into this multicast MAC address. So don't use this method until you know how can we convert multicast MAC address here. Okay, so there are some of the shortcuts to convert it. First step is convert IPv4 second, third and fourth octet into binary. Then set the first bit to 0, whatever bit is coming, set that bit to 0. Convert to hexadecimal code. Then third and fourth octets convert directly to hexadecimal. How do we do that? I have the example here which will actually show how to convert that. So here is the example. It's very similar and simple example. Convert to 24.192.225.30. So I will pause this video and I would like to ask you to convert this IP address into binary first. So once you get the binary, then I will open that binary. So just for 1 minute. Yeah, 1 minute is now almost over. Let's bring binary of 224.192.255.30 here. Here is the binary of all these octets. Then we need to map these binaries to hexadecimal. Write down the MAC address up to 24 bits. I have written here, and the 25th number bit, which is here. So you don't need to change anything up to 24. Here up to 24, done, fine. So we need to take these 3 octets and map it to this MAC address here. So the first bit, this is the first bit, it said make it 0. Yes, make it 0, which is here. So now still we have the same portion, but now the first bit is 0, and the next one I would now map with this multicast address. So how do we do that? First 24 bits as it is, and the 4 is coming here. Now convert this into hex. So 1, 2, 4 and 8. So now this is 0, this is 0 and 0. Cut all these. We have 4. These all bits are 0. Make it 0. 1 means 1, 2, 4, 8. 8 plus 4 plus 2 plus 1, 15. So you can make it F. Here is also F. Then this one 1, 2, 4, 8. 1. Discard all these. Keep 1 here. Then 1, 2, 4 8. So discard this and 2 8. So we have 14 here. 14 means E in hexadecimal. So 1 2 4, not 1 2 4, just a minute. Now it is 1 2 3 4 up to 9. Then 10 means A. 10, I would say 10 equals to A. 11 equals to B. 12 equals to C. Then D. 14's E, and 15's F. So whenever you see these, all these 10 is coming or 13 is coming, you keep these values here in hexadecimal. So here is the multicast MAC address we got from IPv4 multicast address. Let's take another example. It is similar to that. First, convert this IP address to binary. Here is binary of this. Then second, set that first bit 0. So first bit means we will care about only these three portions. We will forget about the first input. So it is already 0, so you don't need to worry about now. It is already 0 means let it be 0. You don't need to change it to 1. Then it's already 0. It's very simple now. Convert this into hexadecimal. So hexadecimal, as you can see, entire portion 0, yes, 0 here. This is also 0, yes, 0. This one 0, yes. 1 2 4 and 8, cross 8 and 1 9. Then 1 2 4 and 8. So cross this and cross this. So we have 2 here. Then again 1 2 4 and 8, cross this. So 8 plus 4 plus 13, D. This is MAC address, new MAC address we got from this IP address. So very simple trick. Only we need to care about first 24 bits, then remaining bits you just first convert into binary, then binary into hexadecimal. Now we can talk about the second category, which is the control plan. As I told, the control plan will define how traffic can be controlled and what are the number of entries and the number of routes available in the table. So mostly control plan talks about the sender and to what group the information is coming from, which IP and going to which group in multicast, and the receiver and for what group. If receiver is also asking for any request, then it is going to what group. This is also controlled by control plan. So control plan is not a protocol. This is the term used for this particular process. And the control plan is actually the combination of all routing protocols and all types of policies, security policies, and the traffic filtering methods. Everything is combined in control plan. So how traffic will be treated, whether it will go to one individual user or it will go to a group or it will be broadcast among a group, that is also part of control plan. And the control plan here in multicast is a combination of what? So these are the two protocols can be used to make this type of situation here. First is IGMP and second is PIM and MSDP. If you are sending information from a receiver, so receiver will ask for a group to its neighbor router. So then it will send IGMP. So IGMP is only used between receiver and the gateway. We call it querier or reporter. Okay, so here IGMP. After that, what will happen? So if you have here, for example, one router connected here, they are part of ISP or anything. All these devices, they will not use IGMP here. They will use now these types of protocols. So here again IGMP. Here it is used called these protocols. These are called multicast routing protocol, PIM. So PIM will be used here between router to router. PIM or MSDP or any type of method, or even you may have any different type of method here. So PIM is used here between router and router. IGMP used between host to router, means recipient to router. I hope this information has been informative for you. We'll talk about some of the versions of IGMP in the next session. The differences between IGMP version 1, 2 and 3. Then we'll talk about what is PIM and IGMP some more in detail. Then we will finish this topic, IPv4 multicast overview. If you like the video, please share, comment and don't forget to subscribe to the channel. I will see you in the next session. Thank you and bye bye.